Semiconductor Packaging. John D. Thomas, Alex Ruth. Book 4, Section 1, Chapter 2, Topic 3, Part 2. Implications and Challenges. A. Integration and miniaturization. The integration of advanced materials, design features, and manufacturing processes enables the development of smaller, lighter, and more compact semiconductor packages.
However, miniaturization poses challenges related to mechanical robustness, thermal management, and reliability. Balancing performance requirements with size constraints requires careful consideration of design, process, and material factors. B.
Reliability assurance. Ensuring the reliability of semiconductor packaging requires comprehensive reliability testing, including mechanical testing, thermal cycling, and environmental stress testing. Reliability assurance measures validate package structural integrity, mechanical reliability, and long-term performance under real-world operating conditions. Implementing stringent reliability testing protocols mitigates the risk of mechanical failures and enhances package reliability. Conclusion: the mechanical behavior of semiconductor packaging is intricately influenced by design configurations, manufacturing processes, and material properties. Understanding the interplay between design, process, and materials is essential for optimizing package structural integrity, reliability, and performance. By integrating advanced design methodologies, manufacturing techniques, and materials engineering principles, semiconductor manufacturers can develop robust and reliable packaging solutions that meet the demands of modern electronic applications. Striking a balance between performance, reliability, and manufacturability requires a holistic approach that considers the synergistic effects of design, process, and materials on package mechanical behavior. Thanks for watching. Please like, share, and subscribe.